Welcome to the deep dive. Today we're exploring something pretty fascinating, this idea of all-weather energy.
Mm.
Think about a city like Philadelphia. Sunshine one day, rain the next, capturing power consistently. That sounds almost like science fiction.
Well, it's getting closer. We're digging into a really interesting white paper today. It's titled Rain-Powered Solar Panels in Philadelphia.
Hmm.
And it looks at, the feasibility, the potential future of this tech, and how it might tackle that classic solar problem, intermittency. What happens when the sun isn't shining?
Right. So our mission here is pretty clear. We want to unpack how this actually works, why it matters for places like Philly, and, well, what the future could hold. Think of this as your quick guide to understanding some really groundbreaking energy tech that's still very much emerging. Okay, so before we get into the rain power part, let's talk about Philadelphia's current solar scene. They've got some ambitious goals, right?
Oh, definitely. The city's aiming for 100% renewable electricity for its own buildings and facilities by 2030. That's a big target.
And they're making progress.
Yeah, quite a bit. There's the Adams Solar Project, for instance. It's a huge 70-megawatt farm out in Adams County. It's already supplying about a quarter of the city's municipal electricity needs, and they locked in rates about 15% lower than the grid price for 20 years.
Wow, okay. That's significant. And I heard something about streetlights, too.
That's right. The streetlight improvement plan, they're retrofitting, I think, 100,000 streetlights. So big infrastructure moves.
And what about regular folks and businesses? Are they getting on board?
They are. Costs have dropped a lot, under $2 a watt now after tax credits. Plus, net metering helps. So you see it even on row homes. A typical setup might generate, say, 10 to 18 kilowatt hours a day. In summer, that can basically zero out your electric bill.
Near zero.
All
Okay.
right, and then you have commercial innovators pushing things further, like Onion Flats. Their front flats apartment building uses these interesting bifacial panels, even on the building walls, the facades.
Okay, so Philly's already doing a lot with traditional solar. But now, the main event, rain-powered solar. How does that even work? What's the science?
Right, this is the really novel part. It relies on something called Triboelectric nanogenerators, or Tengangs for short.
Kangs, okay.
Yeah. And they use the triboelectric effect. It's essentially static electricity, the charge created by friction, like rubbing a balloon on your sweater.
Uh-huh.
So researchers, initially in China, figured out how to layer these specific transparent polymer films on top of solar cells. One film interacts with water, the other conducts the charge. When a raindrop hits that top layer, it's usually PDMS. It creates a tiny charge imbalance. That charge is then collected by the electrode layer underneath, which is often PU-ODOT-PSS.
So the raindrop itself generates the electricity through friction.
Exactly. It converts the kinetic energy of the falling drop into a small electrical charge.
Okay, so you get this hybrid advantage. What are the benefits of stacking this Tang layer onto a standard solar panel, besides the obvious rain power?
Well, the biggest one is that all-weather operation. Since the Tang layers are transparent, they don't really block sunlight on sunny days. So you get solar power then and Tang power when it rains.
Makes sense.
But there's another potentially big benefit, especially for cities: stormwater synergy. Philadelphia, like many older cities, has combined sewers.
Right, they overflow in heavy rain.
Yeah.
Big problem.
A huge problem. Now, solar farms, especially if they have plants growing underneath, are already known to reduce soil erosion by like 90% compared to bare ground. That helps reduce runoff. Adding tangs could take it a step further. You're not just mitigating runoff, you're actually using the rainwater that causes the problem to generate power, turning a liability into an asset, kind of.
That's a really interesting angle. Two birds with one stone. But okay, let's get real. This sounds amazing, but what are the hurdles, the limitations right now?
Yeah, that's a critical question. Practicality. Right now, the energy yield from these tangs is, well, it's tiny. We're talking microamperes.
Microamperes, how does that compare?
It's less than 0.1% of what a standard solar panel produces in sunlight. So, it's not powering your house during downpour just yet.
Okay, less than 0.1%, that's low.
It is low. But you have to see it as proof of concept. Think about the first solar cells. They were incredibly inefficient, too. The key insight here is harnessing rain at all. It opens new doors.
Fair point. What other challenges?
Durability is a big one. These polymer films, they have to withstand sunlight, rain, wind, temperature changes. There are concerns about how long they'll last under UV exposure and physical stress. And then there's integration. Adding these systems, especially ballast-mounted ones on, say, Philly row homes, adds weight maybe 3 pounds per square foot. Older roofs might need assessment. We even hear anecdotal reports, like on Reddit, about solar components like inverters only lasting 5–10 years sometimes. Adding another layer complicates things.
Okay, technical hurdles. What about rules and money? Regulatory economic barriers.
Yep, those exist too. You've got things like municipal fire codes. Some places require, say, a 3-foot clear margin around roof edges, which limits how many panels you can fit.
Oh.
And financing. Regular solar often has zero-down lease options now. 10G enhanced panels. They're experimental. So you're likely looking at higher upfront costs, maybe $65 per square foot or more, just for the support structure, never mind the tech itself. Plus, existing incentive programs like Pennsylvania's SREC market that pays you for generating solar energy, they don't currently recognize experimental tech like TANGs. So no extra credits for the rain power part yet.
Got it. So looking ahead then, what needs to happen in research or policy to make this more viable?
On the research side, a big focus is material science, developing better polymers, maybe using graphene to boost the tang's conductivity and make them last longer. That's crucial. Also thinking about urban design, things like solar canopies, you see them over parking lots or walkways. South Korea uses them. There's talk of them for Philly's Port Richmond Industrial Park. Bigger surfaces mean more rain capture potential.
And energy storage must be part of the picture too.
Absolutely. Pairing tangs with batteries, like the Tesla Powerwall style systems that are already in maybe 22% of Philly solar homes, would be key to smoothing out that intermittent generation from both sun and rain.
Okay, and policy-wise, what changes could help?
Well, updating those SREC rules to include 10 generation would be a start. Maybe streamlining permits perhaps through statewide codes instead of just local ones. You could also imagine targeted incentives like tax rebates for hybrid systems, especially in flood-prone areas like Manayunk, where that stormwater synergy is most valuable.
Makes sense.
And community solar models could play a role. They're working well in New York. Instead of everyone needing rooftop space, you subscribe to a larger shared solar garden. These could be ideal test beds for larger-scale pen trials, bypassing some of the row home limitations.
Okay, so summing it all up, where does rain-powered solar stand?
I'd say it's a really visionary concept, but definitely still in its early nascent stages. The current efficiencies, frankly, aren't practical for mass deployment today. But the core idea, harnessing rain as energy, combining it with solar, linking it to stormwater management, it aligns perfectly with where cities like Philadelphia need to go for climate resilience. It's definitely one to watch. It fundamentally changes how we think about harvesting ambient energy.
So it really makes you think, doesn't it? What if our energy future wasn't just about sunny days? What if we could actually harness the power in every single raindrop, turning something we often see as a problem into a constant source of opportunity, something to mull over?